section 15.4 next. And this will be simplifying and dividing advanced radicals. All right, so a couple things to write down here. When rationalizing a denominator, prime factorize the constant. Then there's a few things to do. I'm going to write all these down and then I'll show you with some actual examples. All right, first thing is multiply the numerator and denominator by whatever is missing to make the index evenly divide into the radicands power. If there's multiple terms, with at least one radical in the denominator, multiply by the conjugate of the denominator. And what a conjugate means is it means you change the sign in between. Just give me a second to copy that down and I'll put all those to use with math. All right, so let's figure this out now. The directions are going to be to rationalize the denominator and simplify what rationalize means is it means get rid of the denominator's fraction. Or get rid of the denominator's radical. And what that means, or how we do that, is we match the index with the radicand. So a lot of English here. I'll show you what this looks like with math. So the square root of 7 over the square root of 3. Just like in life, there's something called manners. If you were to sneeze, you cover your mouth or use your elbow or whatever it is. That's good manners that we learn when we're growing up. Or if you're going through a door, you hold the door open for the person behind you. Those are manners that I'm sure we've learned at some point in time. In math, it's bad manners to have a radical in the denominator. So what we want to try to do is multiply by whatever makes this power match this index. So what that looks like is we'd have to multiply by the square root of 3 to the first over the square root of 3 to the first. Because on the bottom, it turns into the square root of 3 squared. And on top, it's the square root of 21. We don't care about the top. It still stays the square root of 21. On the bottom, it's 3. So now there's no more radical. What if we had 1 over the square root of 2y? Nothing to simplify. This is really a second root with the 2 to the first, y to the first. What we want to do is multiply by something so that our denominator turns into the second root of 2 squared y squared. So we can multiply by the square root of 2y over the square root of 2y. And by doing that, the index matches all the powers. These all cancel. Square root of 2y over 2y would be our answer. The top isn't important. The bottom is where you can't have a radical. And that's what it means to rationalize. How about the square root of 5 over 18? This is really just the square root of 5 over the square root of 18. But before we start multiplying by square root of 18, let's try to simplify. This is just the square root of 9 times the square root of 2. Or 3 root 2. We want to match the index with the power. So if we just multiply by the square root of 2 over itself, we get the square root of 10 over 3 times the square root of 2 squared, which cancels out our radicals. Square root of 10 over 3 times 2 is just the square root of 10 over 6. All right. What if we had the square root of 7 over 20? Similar thing. If we break up the numerator and the denominator, square root of 20 is square root of 4 times the square root of 5, or 2 root 5. Now we have to try to get rid of that radical. So obviously the square root of 5 is the problem. So let's multiply by the square root of 5 over itself. And we get the square root of 35 over 2 root 25. Square root of 25 is 5. So square root of 35 over 10 would be the answer. I'll give you one more of these before we kind of up it a notch. How about 15x divided by the square root of 2x? The index is 2, the powers are 1. We want to multiply by the square root of 2x. So that on the bottom, we get the square root of 2 squared x squared, which cancels out with our powers, giving us just 15 square root of 2x over 2x. So the whole idea is you want to multiply to match the index with the powers of the denominator's radical. All right, maybe 3 more problems left in this section. Different type of problem is if there's a binomial divisor. What we do is we multiply by the conjugate. And what conjugate just means is you change the sign in the middle. So let's say we had a problem like this. I'll just ask you to simplify these. I'll give you 2. Say if we had 4 over the square root of 5 plus 2. Now, if you ever went to an arcade, they have this game called Whack-A-Mole. And with Whack-A-Mole, what happens is you whack one of these things that pops up from the game, and then another one pops up. And then you hit that one, and another one pops up. The reason why I mentioned this is please don't write this down. But if you multiply by root 5 over itself, what's going to happen is the top, it doesn't matter, but on the bottom, you're going to get 5 plus 2 root 5. Obviously, this technique doesn't work because the radical disappears here and it just shows up here. And we have that same back and forth. So if we're multiplying with 2 terms on the bottom, we multiply by root 5 minus root 2. You change the sign in the middle. This is called the conjugate. And on top, we just get 4 root 5 minus 8. On the bottom, if we distribute, this would be the square root of 25 minus 2 root 5 plus 2 root 5 minus 4. It's kind of cool because you almost fake out the numbers. In the middle, you get a negative and a positive, so they just cancel. And you're just left with 4 root 5 minus 8 over 5 minus 4, which is just 1. You could just write 4 root 5 minus 8 as your answer. So if there's 2 terms on the bottom, you change the sign in the middle and multiply by that. Yeah. Right. So the question was, you can't break up a denominator. So if we had 4 over, let's say 2 plus 4, you're not allowed to say 4 over 2 plus 4 over 4. That's totally bad math because 4 over 6 is 2/3. That's the right answer. But if we break up the denominator, this is really 2 plus 1, which is 3. Obviously, it's totally different. So you can't break up a denominator. You can break up a numerator. Say if we had 2 plus 4 over 4. That's the same thing as 2 over 4 plus 4 over 4. Or 1.5. Which is the same as 6 over 4, right? So you could always break up a numerator. You can't break up a denominator. Good question. All right. What if we had 2 radicals? How about the square root of 3 plus 2 over the square root of 6 minus the square root of 5? We still multiply by the conjugate, which means we change the sign in the middle. And we're just multiplying by FOILing like we've done many, many times. The top would be the square root of 18 plus the square root of 15 plus 2 root 6 plus 2 root 5. Bottom would be the square root of 36 plus the square root of 30 minus the square root of 30 minus the square root of 25. Square root of 30 is canceled. So let's see what we get. On top, we have the square root of 18, which is just the square root of 9 times 2, or 3 root 2. The square root of 15 doesn't simplify. Neither does 2 square root of 6, and neither does 2 root 5. So the top is just this mess. The bottom, we get 6 minus 5, or just 1. So as far as your final answer, we could just write 3 root 2 plus the square root of 15 plus 2 root 6 plus 2 root 5. If there's multiple terms in the denominator, then use what's called the conjugate. There is one word problem I just wanted to show you. It's simple, but that's the last one to wrap up this section. And it says, find the area of a rectangle whose length is 5 root 2 and width is 2 root 6. Five root 2 and 2 root 6. The way you find the area is you do length times width. So we're just going to do length times width for 10 root 12. And you should always look to simplify. Square root of 12 is just square root of 4 times square root of 3, which is 10 times 2 times root 3, or 20 root 3.